Tatum, and I will be explaining the sliding filament theory to you. So this top layer that we have here is the thin filament, which has the actin and the tropomyosin and the troponin on it. That's all on the thin filament layer, which is the top layer, this one right here with the orange and purple and all this stuff. And then the bottom layer is the thick filament, which has the myosin on it and the ATP binding sites. So the two heads that link the actin myosin together are during contraction. So these two things bind together when the muscle contracts. And the ends of the myosin filament contain the heads, and there's a central bare area. So these are the heads right here. And then the active sites are blocked for when the muscle is relaxed. So the first step of muscle contraction is the neuromuscular control. And the axon of the nerve cells of the spinal cord branch and attach to each muscle fiber, forming a neuromuscular junction. And this is what we are going to use to represent our neuromuscular junction. And in this, an action potential passes down the nerve, and the nerve then releases NCAA, also resulting in the release of ACH. So this black bead will represent the CA or ACH, and it basically just like comes through the neuromuscular junction and into this little hole here. This isn't like completely accurate, and then it will come through and it will bind with the sarcolemma, so one of the troponin. And so that's the second step. And the third step is muscle fiber action potentials. And we all learned like how action potential works, basically like how it just like equals out. That's what happened throughout, like once the CAA drops, like you had the NA and the K and how they worked out. After the action potential and the NA and K plus, they all depolarize, repolarize, all that stuff. You then start beginning the sliding filament theory of contraction, and during muscle contraction of the thin actin filament, slide over the thick myosin filament. So basically, these myosin heads won't be clipped on yet, and what will happen is when calcium is present, the blocked active site of the actin clears. So after the calcium enters, after I just showed y'all, since the calcium is already in there, the myosin head attaches to the actin. So these little clipper thingies, they will attach to the actin, and the actins are the green things. They attach to the green thingy. Okay, so it attaches to the actin, and then the next step is the power stroke. So myosin head pivots, pulling the actin filament toward the center, so it will move like this. It's just like a simple contraction, sort of like a pull, like that. And then the next step is the cross bridge detaches when a new ATP binds with myosin. And then the last step is cocking of the myosin head occurs when ADP plus P. Another cross bridge can form. So basically it just contracts like that. The last step is the C plus is removed from the cytoplasm, and then the tropomyosin blocks the actin site to relax the muscle. Okay, so the next topic I'm talking about is the rigor mortis, and rigor mortis is something that occurs after death when the ATP is no longer produced, so the muscles stiffen.